Swayam Prabha. Digital India. Educated India.
Hello student, welcome back to the course on optimization methods for civil engineering. So, I have already introduced you on R software. So, we have already learned how to download and the R software, then R engine and R studio. As I said that we are working on R studio, but we have to download R engine and then R studio. So, already I have introduced you what is R, and then we also discuss what is vector, how to define a vector, then what is matrix, then simple matrix operation, vector operations. So, that we have discussed in the last class. So, today I will introduce you some of the more about R. So, how to write an expression, then how to plot a particular function. So, that I will discuss in this particular class. Let us see how we can write a function or an expression on R. Okay. So, let us see. I would like to write this equation. The equation is f(x) equal to x square plus 54 by x. So, this is the code I have given. So, first 3 lines. So, these 3 lines are common lines. So, that will not be executed. So, what I have done? So, this is to write an equation. So, this particular example is to write an equation, and this is a single variable function, and this is example 1. So, already in the last class I discussed that if I would like to write a function, then what I will do, I have to use this particular function keyword. Okay. So, here what I have done, so I have written f1 equal to function and then x. So, x is a variable here. So, this is a variable x. So, we have only one variable, that is your x, and here within bracket I have written that is x square plus 54 by x. So, what I have done x. So, to write square, so what I will do, this is cap and this is square and this is 54 and then by x. Okay. So, this is I have written f1. So, f1 is a function. So, f1. So, here whatever this output of this particular function is stored in f1. Okay. So, this is the variable and this variable contain the function x. Okay. So, now if you look at this is again I have executed here, this will be an equation. Okay. Here you just see I have written that f1 equal to function x, and then I have used second bracket here and I have written the expression here, that is x square plus 54 by x. And now if I execute, then you can see this particular function here. So, you can see that I have executed these 3 lines, then I am getting this particular function, and now I would like to calculate what is the value of this particular function for x equal to 1. So, then what I will do, I will write f1 within bracket, I will write 1, then I am getting 55 here, and f1 for x equal to 2. So, here this is x equal to 2 and here this is x equal to 1. So, x equal to 2 I am getting 31. So, once you are defining the function, then after that for any value of x you can calculate the output of that particular function or output of that particular expression. Okay. So, I hope this is clear to you. So, I can define this function, and if I need to calculate, suppose for what is the value of f1 for x equal to 5. So, what I will do, I will write f1 and then 5. So, if I execute this one, then I will get the value of this particular expression or function for x equal to 5. I hope this is clear to you. Now, let us see another function. This function is twice x to the power 4 minus x cube plus 5x square minus 12x plus 1. So, this is a function and I would like to write this particular function. So, this is what I have to do. This is the code I have shown here, and this code is, so I am writing this is function and I am storing here f3, and this is, so here this is 2 star, this is x to the power 4, okay, then plus then minus x to the power 3 plus 5 star x to the power 2 minus 12 star x plus 1. Okay. So, I have written here and I am defining this particular function. So, if you look at here, so you can see, so this is the function I have defined. So, once I am executing this particular 3 lines, so I am getting this function and then I can calculate the value of this function for x equal to 1 and x equal to 2. So, I am getting this is minus 5 and this is 21. Okay. Now, as I said, suppose I would like to calculate what is the value of this particular function f3 for x equal to 5, then what you will do? This is f3, so you will write 5. So, you can calculate the value of this particular function. So, let us see, this is another function and the function is, again it is a single variable function and the function is f of x equal to e to the power x minus 400x cube plus 10. So, this is the code here and the expression is for f2, f2 is, so here this is exp. So, I have to write this is exp x minus 400 star x cube, okay, plus 10. So, if I execute, then I will get this particular function and then I have also shown then if I need to calculate the value of this particular function for x equal to 1. So, this is I am getting here, this is minus 387.2817 and then this is the value for x equal to 2. Similarly, if I need to calculate for x equal to 3, so I can calculate. Similarly, if I need to calculate for x equal to 5, so I can calculate using this one. So, once you are defining functions or for any value of x, you can calculate the value of this particular function. So, let us see another function. So, this is a multivariable function. So, we have two variables here. So, here we have 10 plus x1 square minus 5 x1 x2 plus 9 x2 square plus x2. So, here I am using vectorized inputs. So, what I am doing? So, I am defining a vector x and this x is x1 and x2. So, if I write x1, that means this is your x1, and if I write x2, so then this will be your x2. So, here I have written 10 plus x1 square minus 5 x1 into x2 plus 9 x2 square plus x2. So, I have written the function here. So, once you are executing, you are getting this particular function, and now if you need to calculate the value of this function for suppose x1 equal to 1 and x2 equal to 2. So, what you have to do? So, you have to define a vector, okay. So, that is your 1 1. So, how we are defining? So, we can define a vector by C, that is 1 1. So, I am putting here. So, this is for 1 1, that means x equal to 1, x1 equal to 1 and x2 equal to 1. So, you are getting 16, and similarly for 2 2 you are getting 32. Suppose I would like to calculate for x equal to 2 3. So, then what I will do? I will write fm2 and within bracket then I have to write 2 3. So, c equal to 2 c 2 3. So, then I will get the value of this particular function. Now, what I can do, I can also give the scalar input. So, in this case, in the function itself, so I am writing this is x1 and x2. So, in earlier case I have defined it as a vector, so which contain x1 and x2, but in this case I am actually giving the argument x1 and x2 here. So, in that case, so I can write it 10 plus x1 square minus 5 x1 into x2 plus 9 x2 square plus x2. So, this is the function I have defined here, and if I execute this particular function, so I am getting this function. Now, this fs2 is there, and you can give the arguments or input for this particular function. Suppose here I am calculating for 1 1, and then I am getting this particular value. This is 16 and this is 32. So, now let us see a multivariable function. So, the function is x1 square plus x2 minus 11 whole square plus x2 square plus x2 minus 7 whole square. Okay. So, I would like to write this particular function. So, here what I am doing, I am using this function. Okay, and I am defining it as a function, and this is x1 square plus x2, and here I have used vectorized input. So, that means x has x1 and x2. So, therefore, x1 means x1 and x2. Okay. So, x2 is equal to x2. Okay. So, I have used x1 square plus x2 minus 11 whole square, then x2 square plus x2 minus 7 whole square. So, I have written this particular function here. So, if I execute this line, so I am getting this particular function, and then if I need to calculate the value of this function for x equal to 1 1. Okay. So, I am putting C 1 1, this is a vector in, I have to give this vector input. Okay. So, this is I am putting C equal to 1 1 and I am getting 106, and for 2 2 I am getting 26. Okay. For this problem, if I can also give scalar input. So, in that case what I am doing, I am defining x1 and x2. So, here again, so now this is x1 is a variable here. So, I am writing as a scalar, and this is also scalar. So, x2. So, I am actually in the argument itself I am giving scalar input. So, this is x1 square plus x2 minus 11 whole square plus x1 square plus x2 minus 7 whole square. So, if I execute this line, so I will get this particular function, and now here you just see this is scalar input. So, therefore, what I have to do, I have to give two input, that is 1 1, and this value is x1 and this value is x2. So, in the earlier case, so what I have done, I put vector input. So, this is 1 1, okay, but in this case this is scalar input. Okay. So, I have also shown here, suppose I would like to calculate the value of this particular function for x1 equal to 1 and x2 equal to 1. So, this is I am getting 106, and for 2 2 I am getting 26. So, in R there is another function that is called AB line function. Okay. Now, AB line is an inbuilt function. So, what I can do basically, so I can use this particular function. So, and to draw a particular line, suppose I would like to draw a horizontal line, I would like to draw a vertical line, or I would like to draw a line, suppose y equal to mx plus c. Okay. So, if I would like to draw a line, so I can use this AB line function. So, now let us see how I can use this particular function, or what purpose I can use and how we can use this particular function. The function name is AB line. The function adds one or more straight line through the current plot. Suppose if you have a plot, current plot, and on that particular plot I would like to draw a line, single line or multiple lines. So, I can draw using this particular function, and This is the syntax for this particular function. So, here I need to define A. If I am not defining, by default value is null, then similarly I have to define B, then H, then V, then the other arguments of this function. Now, what AB? So, AB is the intercept and slope. So, that means if I that y equal to a plus b x. Okay. So, here this a is the intercept, a is the intercept and b is the slope. Okay. So, this is slope. Okay. So, now I can define a and b. So, I can draw this particular line. Similarly, if I write h value, that means it will draw a horizontal line. Suppose h equal to 0 I am putting. So, I can draw a horizontal line through that is at 0. Similarly, if I put v equal to 0, so I can also draw a vertical line at your 0. So, I will show you that one. Let us see this particular function. So, what we are doing basically, that suppose this is AB line, I am not putting the other arguments. So, only I am putting h equal to 0 and I am putting a color, this is gray 60. So, this is the color I am putting. So, before that just I plot this one. So, what is this? This will give a plot, okay, and this is a blank plot I can draw using this plot function. So, I am just drawing one plot. On this particular plot, I would like to draw a horizontal line for y equal to 0. Okay. So, this is y equal to 0 line. Okay. So, what I am doing basically, that I am putting, I would like to draw a horizontal line for y equal to 0 and then I am putting h equal to 0 here and I am getting this particular horizontal line. So, if I execute this particular line, so I am getting this particular line. So, I can draw a horizontal line using this AB line function. So, only what I have to do? So, I have to write AB line and I have to define h equal to, suppose here I have defined h equal to 0, but if I define 1, then it will draw that y equal to 1. Okay. So, a line. So, this is h equal to 1. Okay. So, similarly, suppose on 3 you want to draw, then what you will do? AB line, okay, and in this case h equal to 3. Okay. So, it will draw a horizontal line. Now, if I would like to draw a vertical line, okay, so here at x equal to 0, so this is a vertical line at x equal to 0. Okay. So, x equal to 0. So, now what you will do basically, so you will just write v equal to 0 and in this case color you can define any color. So, I am defining gray 60. So, in this case what I have done here, so I have drawn a line for x equal to 0. Similarly, if I would like to draw a line for x equal to minus 3, so what I will do? I will use AB line, okay, then v equal to minus 3. Similarly, so I can draw somewhere trees here. So, I can draw a line. Similarly, I would like to draw a line for x equal to plus 5. So, what I will do? I will write AB line and then v equal to 5. So, I can draw that v equal to 5 and this is v equal to minus 3. Okay. I hope this is clear. So, I can draw a horizontal line, a vertical line. Now, I would like to draw a horizontal line. Okay. So, this is h equal to 0, that means y equal to 0. Similarly, if I draw a vertical line, then I am writing v equal to 0 and if I draw suppose multiple lines, I can also draw multiple lines here. Suppose here I am writing AB line, that h equal to minus 1 to 5. Okay. So, minus 1 to 5, that means this is minus 1 and this is up to 5. So, I am drawing horizontal line from minus 1 to 5 and similarly here this is minus 2 to 3, okay, minus 2. So, this is somewhere it is minus 2 and this is somewhere it is 3. Okay. So, I am drawing this horizontal line. So, I can also draw multiple lines. Now, if I need to draw a line, suppose here I have defined that y equal to a plus bx. So, here a is the intercept. So, here intercept is 1 and slope is 2. So, this is the line I am getting. Now, if I execute all this code, so what I am doing here, so I have drawn a horizontal line for y equal to 0, a vertical line for x equal to 0. So, this is the first one, and then I am writing the horizontal line for minus 1 to plus 5 and this is minus 2 to 3. Okay. And then I am drawing this AB line. Okay. So, this particular AB line, and I can also write the label this one. So, using the text command. Okay. So, now what this AB line is doing? AB line can be used to draw either horizontal line or vertical line or multiple lines you can draw, or basically you can also draw a line with intercept and slope. Now, there is another function that is called there is another function, the function is curve. So, now if I would like to plot a curve, so in that case I can use this particular function. So, this is for 2D plot. So, draw a curve corresponding to a function over the interval. So, I have to define the interval. So, here suppose I would like to draw this particular function. So, already this function I have defined. So, you know how to define this particular function. So, this function is that x square plus 54 by x. So, this is the function. So, now this function is defined here. So, here f1 is this particular function, and now I would like to draw this one. So, how you can draw? So, you can use curve, and which is your f1. Now, I have to put the limit. Okay. So, I would like to draw this particular function between minus 2 and 2, that means lower bound is minus 2 and upper bound is 2. So, I am putting the limit here. So, I can put the limit that x lim, okay. So, x lim, and here C I have defined this is minus 2 and 2, and I am putting a color red here. So, I have written this code here. So, you can see that initially I have defined this function. So, you are getting this function, and once you are getting this function, you can plot this function using the curve function. Now, suppose I would like to plot this particular function between minus 5 and plus 5. So, what I will do? I will write curve, okay. So, curve, and this is your f1, then x lim you will define now C equal to minus 5 to plus 5. So, anyway you can define color, okay. So, what color you want to use? You can use red, or basically you can also put some number, okay. So, this is the suppose 2 is basically red, okay. So, I can do that, and if I execute that one, so I will get this particular plot here, okay. Now, this is another function, the second function, that is e to the power x minus 400 x cube plus 10. Okay. So, this is the function, and this is your f2. Okay. So, here I have defined this function, this is your f2, and now I plot this function between 0 and 2. So, here lower limit is 0 and upper limit is 20. Okay. And I can also put label, the x label is xx and y label is fun, okay. This is the function, and color is red here. So, you just see I have defined here this function. So, how I am defining that f2 equal to function, and this is a single variable function, we have only x, and this is exp x minus 400 x cube plus 10, and after that I am plotting this function using this curve function. So, this is quite easy. So, I am getting this particular function. Once you are executing this one, then you will get this function here. So, you just see I put the label here. So, this is the x and this is your fun, okay. So, this is, so you can also change your label. Now, I can also plot two function on a single plot. Okay. So, what I will do here, so this is very simple. Suppose I would like to, this is one function. So, this is the first function, that is x cube minus 3 x. Okay. And this is basically, so I have given this is minus 2 n plus 2. So, lower limit and upper limit is minus 2 n plus 2, and then this is the level I am doing, and this is another function, this is x square. Okay. Now, is a C. So, what I have to do here, I have to just write add equal to true. Okay. So, if you are executing the first line, so if you are executing the first line, so you will get the first function. Okay. So, you will get the first function, and on the second function you just write add equal to true. That means what you will do, it will add the second function on this same plot. So, I have to write add equal to true, then in that case I can actually plot two function on a single plot. Okay. So, you can see both the function are here. So, second one is violet. Okay. So, this is the second function and this is your first function. So, I can plot on a single plot. Now, let us see how we can plot a surface, okay, or how we can plot a surface, okay, or you can say that is your 3D plot. Okay. So, for that there are several function, different functions are available. So, I am using PERSP. So, I am using this particular function PERSP. Okay. So, this function is available in R. So, here what I have to do, I have to define the function first, okay, and here this function has to be defined as a scalar. So, that means I have two variables, that is x1 and x2. So, I am defining this function, and this function is x1 square plus x2 minus 11 whole square, then plus x1 square plus x2 minus 7. Okay. So, I am using this particular function. Now, here, so I am defining this particular function. Now, the range for x1 and x2 I have defined minus 6 to plus 6. Okay. So, minus 6 to plus 6, and then I am just the increment I have used 0.01. So, that means the value will be minus 6, okay, and then this is minus 5.9, then minus 5.8, something like that. Okay. So, this is the basically I am using from minus 6 to plus 6 and the interval is 0.1. Then I am using this outer function to calculate the function value at different grid point. Okay. So, that means what I am doing, I am dividing it in grid basically. Okay. So, in grid. Okay. So, here this is minus 6 to 6 and here also minus 6 to 6. So, somewhere 0 is here. Now, at each grid point I am calculating the value of f, okay, and this is for that I can use this outer function. So, once you are getting this particular value of f, so then you can use this particular function PERSP, and then I have to define x1 and x2. So, I have to define what is x1 and what is x2, then what is the value of f, and then at what angle I should get horizontal angle and vertical angle, that is theta and phi, and then these are some of the argument of this particular function, and then color is green here. So, you can see, so once you are executing this one, so you are getting this particular function. So, I can plot a 2D function using this PERSP function. So, this is another function. So, again this is a 2D function, you can see the function is 10 plus x1 square minus 5 x1 x2 plus 9 x2 square plus x2. So, here also, so I am using the sequence function, okay. So, and this is x1 and x2 I have defined here, and this is also minus 6 to plus 6, and then interval between 2 points is 0.1, and then I am using the outer function, and then I am getting the value of f, and then I am calculating, I am using this PERSP function to plot this one. So, I am getting this particular plot. So, code is given here and you can see I can I can basically get this particular function. Now, I can also get this surface plot using PERSP3D. Okay. And for that, what I have to load? I have to load this GA package. Okay. So, in the last class I explained how to install the packages. So, you can use install packages. So, this is GA, and then you have to include it include the library, and here now I have to define what is y and x. So, I have defined it between -10 and +10, okay, and this length is your 60. Okay. And then you are using this particular function. Okay. So, the function is this is a function of xy, and this is the function I have used here to plot this particular function here, that and then you calculate the value of z, that means at each grid point you calculate the value of this particular function, and then I am putting at z. So, I can write z is a function of x y. So, I am using the outer function, and then I am using the PERSP3D. So, the syntax of this particular function is x, y, z, and then you give the angle, at which angle you would like to see that one, and if I execute this particular function, so I will get this particular plot. Okay. So, this is not that difficult. So, here what you have to do? You have to include the GA library, okay, GA package. I can also use the plot ly. Okay. So, plot ly your function to plot the contour. Okay. So, to plot the contours. So, here this particular packages you have to install first. So, this is plot ly. So, this is the or plotly. So, this is you have to install, and then you include this library, and then you have to define the x value and y value. So, here it is between -10 and +10, and then I have defined this particular function here, and this is to plot the 3D plot or to get the 3D plot, and but I am using this contour. Okay. So, this is the contour I am using here, and this will basically show this particular plot. Okay. So, here I have shown the code here, and once you are executing these few lines. So, how many lines? Around 9 lines. So, you will get this particular plot. So, here I have shown a different function, and this function is 10 plus x square minus 5 x1 into x2 plus 9 x2 square plus x2, and here also I have defined this one. Okay. So, this is the x and x1 and x2 I have defined, and then I have used outer function to get the value of f, or you can say z, and then I am using the PERSP3D. Okay. So, to get the 3D plot, and then I use this to get the contour plot. So, if you are executing these lines, you will get the plot, and you can also see that I am getting the color bar here, and the color bar is also showing here. So, you can also put the color bar, and this is for different value of z basically. So, you can see the contour values. So, this is for 50, this is for 150, this is for 100. So, that also you can plot. Okay. Now, again I have used this plotly function to plot the contours here for this particular function. Okay. So, this is x1 square plus x2 minus 11 and whole square plus x2 square plus x1 minus 7 whole square, and then I am using the sequence function, then I am using the outer function, and then I am plotting it using PERSP. Okay. So, this I am using it. Okay. So, I am using this plotly function to get this contour map. Okay. And also the color bar is also here. Okay. So, in this particular class, so I discuss how you can define a function, how you can write an expression. So, that is not difficult. So, you can write an expression, and then how you are defining a function. So, once you have defined a function, then I can calculate the value of this function for different inputs. Okay. So, that also I have explained here, and then I use AB line function to draw vertical line, horizontal line, vertical lines. You can draw multiple lines, you can draw multiple horizontal lines, you can draw multiple vertical lines, you can draw a line with intercept and slope. Okay. So, you can use AB line. So, this AB line is used to plot a line on a existing plot. Then I have used the curve function. So, this curve function can be used to plot a function, and then also discuss some of the function to plot the surface, like your contour plot, okay, and then PERSP. So, you can plot the surface. So, thank you very much.